We are given the matrix M, 3A, 0, 1, where A is a constant. We're asked to prove by mathematical induction that for natural numbers n, m to the power n is 3 to the n, a divided by 2 times 3 to the n minus 1, 0, 1. So, let's start with n being equal to 1. M to the power 1 is 3 to the 1, a over 2, 3 to the 1 take away 1, 0, 1, which simplifies to 3. Then we have a divided by 2 times 2, so that's going to be a. And then we have 0 and 1, which is the same as the matrix we were given up here. And therefore, it is true for the case n equals 1. We then need to assume it's true for n equals k so that we can do the inductive step. So assume true for n equals k. And that means that m to the k would be equal to 3 to the k, a over 2, 3 to the k take away 1, 0 and 1, and now we want to look at the next case. So m to the k multiplied by m is 3 to the k, a over 2, 3 to the k take 1, 0, 1, multiplied by 3a, 0, 1. Now the left-hand side of that is the next case, m to the k plus 1. Now, if we do the top times the left, we get 3 to the k plus 1. It's going to be 3 to the k times 3, and a over 2, 3 to the k take 1 times 0. Then for the top times the right, giving us the top right, we get a times 3 to the k plus a over 2, 3 to the k take 1, and then the 0, 1 times the 3, 0 gives us 0, and the 0, 1 times a 1 gives us 1. So we need to do some work in the top there. We've already got the 0, 1 underneath. So we have 3 to the k plus 1, and then we have, this was supposed to be a times 3 to the k. I think I said that and wrote plus, so quick correction there, 8 times 3 to the k. So that's a times 3 to the k plus a over 2 times 3 to the k. Take away a over 2. And then we've got 0 and 1 in the bottom. And so 3 to the k plus 1. And then we have 3a over 2 times 3 to the k. Take away a over 2. 0, 1. So 3 to the k plus 1. Now we can rewrite this as a over 2 times 3 to the k plus 1. Take away a over 2. We've got 0, 1. And then we get 3 to the k plus 1. And then we can factor out here the a over 2. So we get a over 2. 3 to the k plus 1, take away 1. 0, 1. And you can see that this works, because if you look back at the original, we have now replaced the k's with k plus 1s. So all you need now is a concluding statement. True for n equals 1. If true for n equals k, it's true for n equals k plus 1, and therefore it's true for all n belonging to the natural numbers by the principle of mathematical induction. So let's move to the second part of the question. Triangle T has vertices A, B, and C. Triangle T is transformed to triangle T dashed by the transformation represented by m to the power n, where n is a natural number. We're given that triangle T has an area of 5, triangle T dashed has an area of 1215, and that the vertex A2, -2 is transformed to vertex A dashed 1, 2, 3, -2. We want to find the value of n and the value of A. Now remember, the determinant of a matrix is the area scale factor. Because we have the 0 here, that's just going to be 3 to the n. So the area scale factor is 3 to the n. If we do 1215 divided by 5, the answer is 243, which is 3 to the power 5. Therefore, the value of k, the value of n, we use k in the last part, is equal to 5. Now, once we have the n equals 5, the transformation matrix would be 243. Then we would have 243 take away 1, which is 242, divide by 2, 121, so 121a. And then we'll have the 0, 1. And the point we're transforming, a, is 2, -2. And that would go to 123, -2. So we're just interested in the top row. So we're going to get 243 times 2, take away 2 times 121a, which is 242a, and that's got to be equal to 123. Rearranging gives us 242a is equal to 363. Divide both sides by 242, and we find that a is 1.5.